On your mark, get set, go. We ready? Okay, so this unit is regarding the law of sines and cosines. Beautiful unit. And we start out with a big question, which is many triangles are not right triangles, but they're oblique triangles, meaning they don't have a right angle. So do you remember when we did this? SOHCAHTOA, remember it? So that only works when you have what kind of triangles? Right triangles. So what happens if we don't have a right triangle? Awesome. A squared plus B squared equals C squared is the Pythagorean theorem. Only works with right triangles. What happens if we don't have a right triangle? And so let's see. So we're going to do a short proof today. Hopefully I've taught you that proofs are not necessarily bad at all. This one is one of the nicest proofs that you'll see. It works out pretty quick, pretty clean. So I've got a triangle ABC. Everybody agree it's not a right triangle? So in order to say something intelligent about it, I'm going to make a right angle. I'm just going to drop what we call an altitude, if you remember that from geometry. And we're going to make a right angle. We're going to call that H for height. Now I really have three triangles. Two of them are right triangles, and then one of them is the larger triangle. Agreed? I would like to say something intelligent. I would like to say something intelligent about the relationship between the angles and the sides. Here's where you come in. Folks, I want to say something about angle A, side H, and side B. Sine, cosine, or tangent. Sine. Sine is opposite over hypotenuse. And so I say the sine of angle A is equal to H over B. And by the way, for those of you guys who pursue mathematics a little bit further, like that's all you do is proofs. So starting to learn to think a little bit along those lines is a helpful deal. And then I'm going to say something about angle B and H and A. Can somebody say sine, cosine, or tangent? Sine again. Sine of B is equal to what? H over A. Both those expressions have what? Sine and H. I can solve for H in each situation. If I multiply both sides by B, I get B sine of A is equal to H. And on the other side, I can multiply both sides by A, and what do we get? Good. What do you know? Both those equations are equal to H. And if they're both equal to H, they're both equal to each other. So we now have this equation. B sine of A is equal to A times the sine of B. Notice how on a normal triangle, we would never be given H, and we've just eliminated it from our equation. That's kind of beautiful. I'm going to rewrite it in its last form. I'm going to divide both sides by AB. And you might wonder, why did I choose AB? I just want to make it look different. You're allowed to divide both sides by the same thing. Notice what happens on the left-hand side. And what's the right-hand side? And so we get this beautiful formula. It is called the law of sines. Given a triangle ABC, you have the sine of angle A divided by its opposite side A is equal to the sine of angle B divided by its opposite side B, which is equal to sine of angle C divided by its opposite side C. It holds true for the other angle as well. That's a pretty nice and concise formula, wouldn't you agree? And it's going to work really well for us. We don't even need to do these two examples. We could go straight to your homework. Take out your homework. we have something in front of you called example 1 and example 2. We are right now going to focus on example 1. I'm going to draw a triangle where I have A, B, and C. A is 85 degrees. B is 32 degrees. And side B is 20. In order for the law of sines to work, and please just note, folks, that this does not use SOHCAHTOA. We all agreed? SOHCAHTOA is out the window right now. We don't have a right triangle. But a lot of people find the law of sines easier to use. You just need an angle and its opposite side. Do you have an angle and its opposite side? So that's all we do. We do sine of 32 over what? 20 is equal to sine of what? 85 divided by? Yep, so she wants to find side A. So we're going to do what Ella wants to do. Let me do what Ella wants to do. You sure could. Yep. A. A. Come on, somebody have fun with me. Hey. 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 B. Okay, here we go. So I want to solve here, and I like to save space. Everybody else about saving space and time? When I cross multiply to solve, does everybody agree I'm going to multiply these two, and then I'll end up just dividing by this? Okay, so I'll write this out one time. 2 over 5 is equal to x over 10. If you're going to cross multiply and solve, you get that times that is 20 is equal to 5x, right? Whatever multiplies to the variable, you just end up dividing it back off. Agreed? So when we look at this cross multiply and try to do it quickly to save time, which you all like, we're going to multiply those and we'll divide it by that. Yes? Okay, so I'm going to take my calculator. Let's make sure we plug it in correctly. Got to have a calculator for this unit all the time. I'm going to take 20 times the sine of 85. And notice how I close the parenthesis on the 85. And then I divide by the sine of 32. And I press enter. And I get 37.60. And that was side A. That seems like a pretty lengthy side. Should that be my largest side? Yeah. Why? Because it's going to have the largest angle, isn't it? Yeah. Okay. So look at what we got. Okay, we've got that. Also make sure that your calculator is in degrees. We're not in radians right now. Question, Ella. So for the rest, do we have to do that again? Or can we just do... Excellent. Can't use Pythagorean theorem because we don't have a right angle, do we? So we're going to set it up again. Can I find angle C now? Yeah. Can't use a squared plus b squared is c squared. Nope. So 180 minus 85 minus 32. Now I get 63 degrees. So somebody set up the law of sines so I can find side C. Sine of what over what? Yep, you can use 32 over 20. If you wanted to, you could also do 85 over 37.6, but we'll use sine of 32 over 20 equals what over what? Sine of 63 over C. Good, sine of 63 over C. And notice I'm at this point again where I'm going to multiply the 20 and the sine of 63. And then I'm going to divide by the sine of 32. And I get 33.63. Sine of A over A is sine of B over B is sine of C over C. No. Okay, here's what I want you to do, folks. I'm going to give you about 4 minutes. I want you to try problem 1. Don't try problem 2 yet. Try problem 1. Ready, set, go. We good? Okay. All right. This is the most critical part of the day. By far the most critical part of the day. If you don't get this next 7 minutes, the test is going to be significantly challenging for you. So I need to bring up something that you covered in geometry but didn't sink in real well. And it's not a moment where you guys will walk away being like, oh, I hate geometry, I don't remember it. It should be a moment of like, I never understood that the first time around. Get my point? So let me clarify something. Look at this triangle right here, okay? This triangle right here, I've got, it's set up just like this. If I set up this triangle and I go A, B, and C, I got 40 degrees, I've got 10, and I've got 7. Want you to spend 40 seconds and talk with your peers and decide what makes these two triangle setups different from each other. Go. Okay, 5, 4, 3, 2, 1. Okay, what do you got? What do you got? What makes them different?
One's SAS and one is AAS.
Okay, all right, thank you. Not necessarily, but good idea. The idea is that there are 2 angles here, and here there's just 1 angle, right? Here there's just 1 side, and here there are 2 sides. We all good? Now, classifying the triangle is important. And so what I need you to do right now is decide, and it matters, and this is where people start to fall apart. This is 2 angles. So you know it's not this one, right? It's either AAS or ASA. You decide. Take a minute, talk, go. One, is there anybody out there that knows for sure?
Angle side angle.
Okay, shut up, Trey. So, Patrick, you said it's angle side angle. Why are you so confident? Okay, watch. If I start at the 85-degree angle and I go around clockwise, I go angle side angle. See that? That has nothing to do with it, folks. Nope. Nope, has nothing. And then look, if I start at the 32 and I go clockwise, I got angle side. And if I go reverse, I got angle side angle. If I start at the 85, I got angle side. Rotation has nothing to do with it. Get it out of your brain. Are you ready to learn why? Watch. See the 85-degree angle and the 32-degree angle? Which side sits between 85 and 32? Which side is this that sits between the 2 angles? Side C, right? That's not 20, is it? If the side sits between the 2 angles, then it's angle side angle. See the difference? 20 does not sit between the 2. See how the side does not sit between the 2? That's the difference. So this situation here is, in fact, angle side, not angle side angle. This one has 2 sides. You know it's either that one or that one. Take 40 seconds, decide which one it is. Go. Okay, which is it? Yep.
Side angle side.
Excellent try. It is side angle. Avery, tell us, because you're 100% correct. Why is it side angle? Okay, so Avery said this. She said if 40 degrees would have been sitting here, then it would have been between the 2 sides.
Oh, I thought we were trying to find B.
Okay, I understand what you're getting at. We need to revise that thinking just a little bit. Watch this, okay? You gotta wake up, okay? Gotta wake up because you want to see this. You want to see this. You want to see this. Look at this. If you have the side of 10 and the side of 7, can you see that B is in between those 2 sides? And you are not given that angle, are you? This angle has nothing to do with the side 10, does it? So therefore, it is a side angle. It does not sit between them. So here's what you need to do. Flip over your papers so that you can see this thing right. Where is it? Come on, Gens. Where is it? There, this thing. Your notes, very last page. These are the notes you get to use on your test.
Oh, let's go.
There's a few things in education that I'm very proud of. This is one of it. I spent a lot of time putting this together, and it seems to work really well for people. And so I'm going to explain it to you very, very, very precisely. If you're given angle, 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 that was not a congruence theorem in geometry. You may not solve that angle, the triangle. Doesn't work. But if you're given angle, angle, side, that was a congruence theorem. And there's one solution using the law of sines. If you're given angle, side, angle, there's one solution using the law of sines. We've already solved triangles like that. But if you're given side, side, angle, then that causes a problem. Do you remember backwards it spells donkey? Yeah, that's a problem, isn't it? So we follow it down, and we try to decide. If we're given side, side, angle, what do we do? Side, side, angle. Is the side opposite the angle longer than the other given side? Or is the side opposite the angle shorter than the other given side? Let's look. Is the side opposite the angle longer or shorter than the other given side? It is longer. So what does it say? Yeah, exactly. It says if it's longer, then we have one solution and we use the law of sines. Today, when you do problems on the right-hand side, they will all work out like that. Tomorrow we got to investigate what happens if that's not the case. So let's check it out and let's see it through. Here we go. Sine, I'm going to write 40 degrees here, and I'm going to write 10 for A, and I'm going to write 7 for C. Do I have an angle and its opposite side? Yeah. So help me set it up. Sine of what over what? Sine of 40 over 10 is equal to what over what? Sine of C over 7. Notice I'm not solving for a side, am I? What am I solving for? An angle. That's going to be different. I want to solve for the sine of C. I can multiply both sides by what? And I would get 7 sine of 40 over 10 is equal to the sine of C. So I'm going to come up with a value there. I go to my calculator, I turn it on, and I go 7 sine of 40, and I divide by 10. 0.44995. Miss Laura, if I am looking for an angle, do I press sine or do I press second sine? Because you're doing sine inverse. She's absolutely right. You go second sine of 0.44995. Now, you guys, I want you to know that you don't have to write that decimal down. Look, my calculator had this answer right there, right? So you could just go sine inverse, and instead of retyping, you could just go second, and then A and S is answer. It just takes your previous answer and throws it in there. You get 26.74 degrees. Awesome. I've got angle C. What's the next one you want to find? Yep. How do you find B? 180 minus 40 minus, like you said, 27 or 26.74. I'm going to go second answer, just throws it right in there, and I get 113.26. Should I use the Pythagorean theorem? No, it's not a right triangle. So I have to set up the law of sines again. Sine of what over what? Good. So as we follow our cross multiplication, I'm going to do 10 times what? Good. 10 times the sine of 113.26. And I'm going to divide by what? Divide by sine of 40. So you can show all your work at cross multiply, but I think we've learned how to cross multiply quickly over the years. And so setting that up is all the work I need to see on the test. I got 14.29. That's the biggest side. It's got the biggest angle. Looks like I'm good to go. Everything on the right-hand side, you're going to be looking for a side first. Or on the left-hand side. Everything on the right-hand side, you're going to be looking for an angle first, and therefore you'll need to use arc or sine inverse. Okay? So everything on the left-hand side works out like that. Everything on the right-hand side works like that. Here's the deal, you guys. You're going to go through this, and you're like, Gens, I don't need 8 problems. I did 4 of them. That was enough for me. You guys, we want to put these towards application problems. It does get more difficult, so you don't just want to know how to do it. You want to know how to do it quickly, okay? So you want to find yourself catching a little bit of rhythm and confidence when you go through these. All right? So you go ahead and start working on it right now, and I will post the answer key.